working? Yes. This is giving us a graph of f, okay? And then I'm defining h of x is this weird function, -1 plus the integral of f. But all that tells me, gang, okay, the whole point of that, h being the integral of f, even though it has a stupid -1 out front, that doesn't change much. This tells me right here two things. It tells me that h prime of x, if you derive that, right, there's a big plus in the middle, so we derive separately, right? -1 derives as 0, so technically it's 0 plus, and the derivative of this integral is just f of x. So h prime is just f of x. That's the first thing that tells me. It also tells me, if we need to know this, that h of 2, I'm using 2 because that's where I'm starting on my integral, is -1 plus the integral from 2 to 2, right, of f of t dt. That's a 2 up there. Zoomed in too far with this pen, but oh well. But the integral from 2 to 2 is just 0, so h of 2 is just -1. So that's what we know. We know 1 point on h of 2 is -1, and we know h prime is f of x. Cool, so let me move that out of the way. But those are facts. Facts. There we go. All right. Now, we want h of 6. Well, we have a rule for h of x. It's right here. So h of 6 is going to be -1 plus the integral from 2 to 6 of f of t dt. That's not bad. Now we integrate in 3 ways really right now. Okay, there's going to be a fourth coming eventually. But it'll spell out which way they want you to integrate. So we can either integrate by hand, right, using calculus. We can integrate with a calculator, right? So those aren't really different, but calculator is different. Or we can integrate by finding area so far, all right? And in this case, since I don't have a function for f, I just have a graph of it. I'm going to integrate it by finding the area under its curve. So that's from 2 to 6 in this case. So I need -1 plus the area from 2 to 6. But luckily for us, the area from 2 to 6 is just this dumb triangle. Okay, so that triangle has an area of 1/2, which is 4, right, times the height, which is -3. Because it's below the x-axis, that's going to give us back a negative change. What that means is, again, keep in mind, h, this is its derivative. This is h prime we're really looking at here. It's f of x, but it's h prime. So if h prime is negative on this interval from 2 to 6, then h is decreasing. That's our big rule. And how much is it decreasing? The area that's in there. That's all we're saying. So the area in there is what? 6. So it's -1 minus 6, which is -7. And we expect h of 6 to be less than h of 2, right? Because h is decreasing from 2 to 6. All right, and to find h of -5, that's -1 plus the integral from 2 to -5 of t dt. Okay, now, one thing I will tell you here, if I was integrating this on a calculator, I don't care about the limits being upside down like that, having a -5 above the 2. If I'm integrating by hand, like using actual calculus and plugging in, it does not matter if the limits seem, if you're going backwards, right? We're integrating from 2 to -5, so we're kind of integrating backwards on the x-axis. It doesn't matter if you do it by hand or with the calculator, it's going to work itself out. If you're integrating by hand backwards, though, and you're going to find areas, it makes sense to rewrite this as this. We talked about this yesterday. It's the same thing as -1 minus the integral from -5 to 2 f of t dt. Remember, you can flip those limits, and we want to do that because when you find area, we just inherently are finding it left to right. Okay? You can find it right to left, but then you got to remember it's the opposite of what it was supposed to be. And the reason for that is, the reason why that happens, again, is because you think about, we're kind of going back in time. So we're undoing the change. We're subtracting the change off. Okay? Yeah. Like if you went uphill on a roller coaster, but you had to go back in time, you have to go downhill on that roller coaster to get there, if that makes any sense. So that's why that becomes subtraction. But it's still just an area question. This is just -1 minus, we got to find is up here, from -5 to 2. So let's just do this up here. This is a trapezoid right here, right? The area of a trapezoid is 1/2 the height, which is -2, times the sum of the bases, which is 1, 2, 3 plus 2, 5. Stop me if you're unsure about anything, but that is that trapezoid right there. And if I mess up, let me know too. Area in that semicircle, which is what we need as well, because we got to get up to 2, right? So what's that? Negative 10. This is like negative 5. Okay, area in here is negative 5. Boom. Area in the semicircle is a half pi r squared. But pi r squared, r is 2, right? Y'all see that. So it should be 4 pi. So the area in each of these is pi. Thing like that. Or you can just write 2 pi, the big circle, semicircle. Okay? So that means the area in there is negative 5 plus 2 pi. So that's what goes in here. Is my integral. Negative 5 plus 2 pi. That's all we're doing. So that's negative 1 plus 5. That's, 4 minus 2 pi. Says, again, you can do this without really thinking about what's going on here, but what these areas say is this. Let me try this. From starting at negative 5 here, right? Let's say we started at negative 5 right here. So that's negative 5 something. I don't know what, but negative 5 something. We go down 5. That's what that says. And then we go up 2 pi, which is like 6.28 something. So it goes up, boom, like that. And we get to here, this is going to be a 2. And then after that, we go down 6. So it's going to take me back to here. That's H has to. All right, it goes down, then up, then down. That's what our derivative says, down, up, down. Okay? Areas tell us how much change happens. Okay. B says the minimum and maximum of H on this closed interval. So even though this is a graph and we got some integral function, finding the minimum and the maximum are the same thing always. Find the derivative, find where it's 0, check those values. Okay? So everybody good? I'm going to erase all this other work. Any more room. But everybody good? It's happening. No takebacks. All right. Cool. Anybody do Symphony of Lights yet? Hello? Zoo lights? Anybody out there do that? Are you guys too cool for that? Okay. Good talk, good talk. Well, I'm going to take my kids to Symphony of Lights and the Zoo Lights, and I'll let you know how they are. Cool. In case you want to take a date there or something. Can you guys even go on dates with COVID? You guys could be at separate cars. FaceTiming. 2020. Okay. I'm just rambling. I'm like an old man rambling to myself in an empty house right now. That's good. Okay. Anyway, we want the minimum value of this thing. So first thing we need, and you need to write this, okay? So on the AP test, here's not a huge deal, but on the AP test, you got to show, hey, I need the derivative, which is I get a point for that a lot of times. We need that. Now, I can look at the dumb graph and see what happens. F of x equals 0. When x is, these are going to be nice numbers. Negative 2, 2, and 6. Everybody okay? So all I need to do is find, and I wish I would not have erased my numbers that I just found there. I need to find, for question B, I need to find h of the endpoints, negative 5. H of 6, we need to find that, which we actually found those in the last question. A lot of times the AP tests will do that for you too. They'll set you up to find some stuff you need for the next question. Okay, so what was h of 6? It was negative 1 minus 6. Was it negative 7? And what was this? Negative 1 plus 5, 4 minus 2 pi. Is that what it was? Okay. And then we got to find h of these other values. So h of negative 2. Remember, the area in here is 2 pi. H of 2 is given to us, right? We already knew that it was going to be negative 1. That's not bad. Okay. 4 minus 2 pi is a negative number, by the way, guys. It's like negative 2 something. All right. Yeah, and that's it, right? Yeah, we need h of negative 2. So h of negative 2 is negative 1. It should be plus the integral, right, from 2 to negative 2 of f of x dx. But remember, I don't want to integrate backwards when I'm finding areas. Okay, that's the only time I really don't want to do it. So we're going to switch that and make it go from negative 2 to 2. So h of negative 2 is really negative 1 minus 2 pi, which, that's it. That's the answer. So the maximum is going to be the greatest number, right? The minimum is going to be the lowest number. But again, you can see here, guys, it goes down 5. That's what's happening here. Up 2 pi, and then down 6. Okay? So the maximum has to happen at 2. All right? Because that's you can see on the screen. Look here, that's where the derivative goes from positive to negative, right? This thing, again, it goes down, up, down. So, I mean, I guess it could be an endpoint, but it goes up more. It goes up 2 pi when it went down 5. All right? So that's why I know that has to be the max. Anyway, you can also check these numbers out. Whichever one's the largest is the max, whichever one's the smallest is the min. And yeah, you got to kind of eyeball this a little bit, but you can see that so 4 minus 2 pi-ish is what, like negative 2.28-ish, right? Negative 1 minus 2 pi is like negative 7.28-ish. Cool. Oh, so h of negative 2 is my minimum? Because it went up 6.28 and then down 6 again. That makes sense. Yep, that's right. Okay, so you'd write that. The absolute max is, I forgot, h of 2, which is negative 1. And the absolute min is h of negative 2. That's an h, not a 2. Which is negative 1 minus 2 pi. You want the real value, not that negative 7.28 estimate there. Questions? Feeling good? Okie. And then C says find the average rate of change of h from negative 5 to 6. That is h6 minus h of negative 5 over 6 minus negative 5. Okay, and we found those values. Like h of 6 was negative 7, so just plug into this. Negative 7 minus h of negative 5, which is 4 minus 2 pi. Just plugging it all in. Over 6 minus negative 5 is 11. So this is negative 7 minus 4 is negative 11 plus 2 pi over 11. There you go. That's just the slope f has, or h has, from endpoint to endpoint. Okay.